Hey, so we're doing a DC motor closed loop control. Essentially, this thing looks super busy, but what's happening is we're reading the motor rotations here, kind of position here, and then we convert that to RPM. And then we pass in a desired sort of RPM. So in this case, we put in sine wave. The sine wave fluctuates between 2000 and 6000, and you'll see that here. So something like this is where your output will be. So the red line is where you want to be. That's what your desired state is. And the blue line is where you are. So initially when we put too much voltage, and so we sort of overshoot, and then our control system should be able to correct for it. So that's what's exactly happening here. So we are, instead of just keep going into the universe, we are coming back and sort of following the sine wave. And so you see it's not perfect, right? And your goal is to try to make it as close as possible. There are trade-offs. So if you try to make it perfect, you would obviously sacrifice some of the RPM. So you probably never reach superior, higher 6000s or lower 2000s. But so you kind of find a sweet spot that's good enough. But you definitely want to, get rid of these things. These are especially like any overshoot. So you might have some tolerances, can't go above 6000, so on. Okay, so without further ado, how do we control? We say it's like, hey, sign goes positive and negative. We want to always keep it positive, so we put an offset. So you'll see here amplitude is like 2000. So if we add, if you get negative 2000, then we can add 4000, it brings it back to 2000. And then if it's positive 2000, if you have 4, that goes to 6. And that's why our graph is like between 2 and 6. Frequency has to be like really, really small. So 0.2 hertz in this case, and then we have a sample time. Okay, so it goes in, just as data type conversion. We can check our desired RPM here. And then we have a KI control. So, PI control. So this is proportional control, and this is your integral control. So here we are sort of, watching the error for a while, for a time period. And then we are correcting for it. Here we are directly, multiplying. So let's say you are at 10, but you're supposed to be at 12. So what I could do is increase you by 20%, right? That direct increase is handled by proportional control. So it's proportionally increasing. Okay. And then down here, I'm making sure that there's always some minimum amount of voltage, so the motor doesn't like stop. So that's just a bias or offset for the motor voltage. And basically, I'm able to send my data back to Arduino saying that, hey, this is how we're going to send the pulses, voltage pulses to the to my motor, which is down here. So the last thing to note is this motor has these two bunny ears. That's the encoder, and then those read. The bunny ears are basically reading the position, and you pass that information through what's happening here? So some voltage fluctuate. Looks like some wire is not properly placed. Probably power. Okay, I'll take care of it. So the green light is good. The green light there is good, and the red light, that's an edge bridge. So it controls like the polarity of the motor, and you can control multiple motors. This is just ground, and these pins are essentially giving data. So this green and yellow are going into pin 2 and 3 is where we are reading, where this motor is right now, position wise. And then we are sending on-off signal to the next green and blue wire beyond that. And then the purple wire is actually flipping the motor. White and red wire are first and second, last wires on the encoder, red is power, and I think white is again position control for the encoder to know where we are. Okay, with that, when we run it, you just saw the sine wave, so I'm not gonna run it. Takes a while, but the code will compile and send the hex code to the board, the microcontroller, and you'll get something like this. We do want to see the motor rotate, obviously. That would be cool. So right in a second, what I'm gonna stick this on the motor so you can observe the motor rotate. There we go. So you see slow down, that's when it was going to 2000 RPM. Now it's going up again, slightly. Well, you get the idea. And we can... Okay, let's look at the graph quickly. So right here, I'm gonna plot my RPM and desired stuff, and voila, you get kind of the same thing, just slightly better. All right, thank you so much.